For centuries, humanity has gazed into the night sky, asking the same eternal questions. How far does the universe stretch? How insignificant are we in the grand scheme? And is there a limit to what we can truly comprehend? Now, an answer has arrived, one that didn't come from myth or imagination, but from the most powerful space observatory ever created. The James Webb Space Telescope, floating nearly 1 million miles from Earth, has sent back data so astonishing, that it's forcing scientists worldwide to rethink everything we believed about the structure and age of the universe. Galaxies appearing where there should be emptiness. Black holes forming when the universe was still in its infancy. Stellar nurseries, once hidden, now revealed in extraordinary detail, letting us witness stars being born in real time. And this is only the beginning, because with just a single observation, Webb didn't merely expand our view of the universe, expose something far greater. A truth so vast, so complex, and so utterly beyond imagination, that it may redefine our place in the cosmos forever. The James Webb Telescope wasn't just designed to follow in Hubble's footsteps. It was engineered to transcend them, to become a time machine capable of capturing the faint glow of the very first light after the Big Bang. With a mirror over 6 times larger than Hubble's and cutting-edge infrared sensors, Webb can see through the thick clouds of cosmic dust that once obscured the birth of stars and galaxies. It was built to peer not just millions, but billions of years into the past, and it delivered. When the first images arrived, scientists were left speechless. The empty void of deep space, not empty at all. What once appeared as faint, isolated smudges were revealed to be vast oceans of galaxies filled with countless stars, planets, and perhaps even life. But the most disturbing revelation wasn't how much there was. It was when it appeared. The timelines didn't add up. Galaxies and black holes were forming far earlier than our models predicted, suggesting that something about our understanding of cosmic evolution is deeply, fundamentally flawed. And now, the question isn't just how far the universe goes, it's whether we ever truly understood it at all. Webb discovered something no one expected: galaxies. With complexity far beyond their age, spirals, bulges, and even traces of cosmic dust, in a universe that, by all our models, should still have been forming. These galaxies were only a few 100 million years old, yet they already showed signs of structure and maturity that defied every prediction. How could this be? Either the universe evolved much faster than we ever imagined, or there's something far more fundamental we've misunderstood. Music fades in as the telescope peered deeper into the cosmos. A hidden architecture began to emerge, a vast, invisible web of dark matter and gas stretching across billions of light years. Regions of space once believed to be empty were suddenly alive with galaxies. Aligned in patterns that challenged the idea of randomness, they were connected, linked by massive filaments of gas. Cosmic highways that directed matter and energy across unimaginable distances. And Webb wasn't just seeing these structures, it was measuring them, using its advanced spectroscopic tools. It began to map the chemistry of ancient galaxies, the temperatures of intergalactic gases, even detecting the signatures of life-building molecules adrift in the coldest reaches of space. What emerged was a new vision of the universe, older, more dynamic, and far more interconnected than we ever believed. Galaxies weren't just floating in isolation. They were merging, colliding, consuming, and nurturing one another, not as random chaos, but as part of a grand, turbulent dance written into the fabric of time itself. And within that cosmic dance, one truth stood out: the universe was never born in silence, it was forged in fire. Music swells. What makes Webb truly revolutionary isn't just how far it can see, it's how long it watches. For the first time in human history, we are witnessing the evolution of the universe. In real time, Webb's long-duration observations have opened a window into the cosmos unlike anything we've ever seen. We've witnessed stars being born, others dying, some collapsing into black holes, and others erupting in brilliant supernovas. In galaxies, unimaginably far away, we're observing the light of stars that flared to life billions of years ago, before Earth even existed, and yet we're seeing them now. But the true surprise came when Webb began studying exoplanets and their atmospheres. Using a technique called transit spectroscopy, It analyzed starlight filtering through the skies of these distant worlds. And within that light, it found astonishing traces: water vapor, methane, carbon dioxide, and even complex molecules, considered here on Earth to be the very building blocks of life. It wasn't direct evidence of aliens, but it was perhaps something even more profound: proof that the ingredients for life are not rare. They may be common, scattered across the universe like seeds, waiting for the right place to take root. But Webb didn't stop with stars or planets. It kept looking further, deeper toward something even stranger.